Mr. Lakshmanan Sethu's video regarding RAG.
So yeah, anybody like, are you able to see my screen? Can somebody confirm, Krishna or somebody else, so that, I can get started?
Yes, sir.
Okay. Okay. Thank you so much. So as we discussed, so yeah, today's topic is grounding generative AI enterprise search solution with RAG architecture. Uh, so let's for a quick intro. This is Lakshman, and I work as a technical account manager for Google in Bay Area at the moment. So I help enterprise customers, uh, you know, to innovate with Google Cloud AI and ML solutions. It's been pleasure to meet you all. So let's get started. So these are the rough topics that we're going to cover. But let's get started about generative AI. I would love to this session to be a little bit interactive. So anybody have any answers on what is generative AI solution before I dive deep into my slide. So just somebody can give rough introduction, that would be super helpful. Anyone out there to give a guess about what is generative AI solution, why it has become popular? I mean, there is no right or wrong answer, but just want to be make sure this session is more interactive. Okay, then yeah, let me get started then. Yeah. So what is generative AI? So generative AI is a branch of artificial intelligence where, which gets really popular after this chat GPT by OpenAI. It's pretty trivial from the name. So generative AI, it's all about generating the content with the help of artificial intelligence. So when I say content, the content can be a text, which is a chat GPT. The content can be which is like Gemini and chat GPT. Gemini is from Google and chat GPT is from OpenAI. These are the two most pretty popular and used uh, generative AI chatbots or generative AI models available in the market. So uh, yeah, when I say generative AI, it can be used to generate not only text, which we are most of us aware of it. Can be used to generate images. For example, Imagen is one of the model where you can just write a description of saying, for example, or can you provide me the picture of IIT campus in Gorakhpur with few students standing in front of the entrance. So it could give a rough image. It can generate a rough image. This is also one of the image generating model. There are a lot of models out there. So Midjourney is one popular, and Imagen is another one. So that is like with text, images. You can generate video also out of it. So you might have heard about the latest announcements from Google as well as OpenAI on those project Astra, where you can generate video out of it, and ChatGPT, OpenAI is
मेरे बैग से मेरा ला
also
बोलेगा
maybe write
वो
something on the
और मेरे
video,
को पानी
it
दे
will
रहा
generate a
है
video from there. So and else the most popular one is creating the code. Since I'm coming from the uh, technology industry, so it helps the developers to write the code for the solutions as well. So it can be used to generate any sort of content. To put it simple, like it can be a text, it can be a image, video, audio, code, and whatnot. So that is what is called generative AI. It takes pretty popular since for the last couple of years, and right now most of the organizations or the enterprises that I work with have started implementing, baking this generative AI solutions into everywhere, right? So uh, so that's what it is. So this is the
गर्म ही
slide,
बेटा मैंने
like,
बॉटल में बात
how
नहीं
it is being
मेरी बॉटल में
possible.
है गर्म वही दे दे
We call it like generative AI model. In ML world, is it's a model, right? A model is a piece of code that helps predicts or
हेलो
generates the outcomes, right? So for example, machine learning model, which is here, it's called LLM, which is nothing but large language model, because it's pretty common from the word large language model, due to the fact that it's trained on the large languages, like the most of the mm, uh, content, right? So it's like, it can be and it can be text, it can be images. That's how it is able to generate those content for us with the help of our input. So we'll go deep into that, but how it is possible, right? So it will try to, you feed so much amount of data into those model, and it always tries to predict the next pattern or next data, right? So that is how it is possible, and all those data are stored together in a database called, which is we call it vector database, so that it understand the meaning of those words, and so that it is easy to come up with some you know response. For example, you can ask those generative AI model like how to make a cup of coffee. It can come up with pretty detailed answers. Like boil the milk and then add all the step by step, right? I mean, so which is like it understand the user meaning, like the search people, the people who are using it meaning, and then it comes up with the steps. So it's like baking the intelligence into the machine learning models with the help of uh, embeddings. That is the core concept behind this generative AI model. So you train this model with whole amount of data across the globe, and based on all those data trained, it stores all the data in a vector database based on the similarity. For example, apple and juice will be stored pretty much next to each other, and apple and iPhone will be stored pretty much next to each other. So it depends on the context, it generates the content for us. So this is pretty detailed overview of generative AI solutions. I'm going to take a pause here. Let's see if you have any questions. Please raise the hand. I mean, any questions so far? Okay, thank you, madam. So but let me know if I'm covering the basics. I mean, there are like 38 professors out there. Like, let me know if you know something. Like, can you go a little bit deep on specific topic? I'm happy to cover. But I have made the deck like it can go very deep as well as it can stay at the surface level. So please keep me posted at any point of time. Hey, this is what we have learned in the previous classes or previous session. Let me know. I'm happy to skip it and add replace it with another text. Okay. So as I told you, there are some examples out there: text generation, image generation, audio generation, code generation. These are the publicly available tools available. Like it is becoming now subscription based. Imagen is from Google, Gemini is from Google, Midjourney is another provider who creates image generation possibilities, and code generation is Duet AI is from Google, which is now it is called Google Cloud Assistant. Copilot is from Azure. So this is pretty interesting. Code generation, like you can ask this chatbot or this assistant, say like, hey, can you generate a Python code to pull in the data from a spreadsheet and predict, and put it into, create a analysis map of, X versus Y, right? So then the code generation model can write a piece of code for you so that, it helps with the code generation for developers. So if you see, this possibilities is not only helping to revolutionize um, only certain industry, for example, banking, finance, and media and entertainment, any industries, right? It's all been, it's been pretty much been now they started using some sort of generative AI solutions. So you see that most possibilities of this generation is also there are other use cases which we can go deep, like for example, uh, classification, maybe sorry, summarization. You can give 100 and let's say you can give 250 pages PDF to this generated AI solutions and say like, can you please summarize this, right? So let's say you have a whole lot of content, but you want to understand the concept in a simple way, but you don't have a time. Let's say you have since you're all professors, I would say like, let's say you have a course on any of the computer science topics, for example, deep learning, machine learning, or anything like, let's say you have a research paper published, and you want to refer it in your research paper preparation. Like, let's say you don't have a time to go through those 10 pages. You can ask those generate AI models to, create a summary out of it. So it can easily create a, like 10. You can give whatever the way you interact with the model is called the prompt. Like whatever the input to the model is called prompt, right? So the output is expected output is either gen text or image or audio or code. So the way you interact with generate AI model is through called a prompt. So it's called that is the input to the model. You can that is the plain English. You can talk to this model like you talking to the human beings, right? So that's why this, like, you can talk to the model saying like, hey, can you please read this research paper from this PDF or from the content, and summarize me in a paragraph or in in 10 sentences and highlight the summary, so it can just read it for us and then do a summary. But that's the closest example I can think of for the all the professors, researchers out there. So similarly, it can be used to create content for the marketing, media, video, audio, and all those things. And for banking also, you have lots and lots of policy documents, and you can create a chatbot out of it. It can answer those questions in a way that human understand and answer. So that is the power of generative AI solutions. So next concept is called a semantic search. So any guesses what is called semantic search? Anyone and any of the professor like want to guess on what is called semantic search? Okay, so let me get. So ideally, how many of you have used the Google search, right? So how do you search through the Google search? You use keywords, like for example, how do I go to this Delhi campus, right? So you search those, what is the Delhi campus address? Uh, you know, that is called, it used to be keyword search, like it matches the keyword and it gives the output. But how semantic search is pretty different from the keyword search, where it understands the meaning of the search and the context of the search, right? So that is what is possible with the help of generative AI. So gone are the days like uh, when the system is able to identify whether you are talking about apple the fruit or the apple the iPhone, right? Due to this the vector database which I talked about, right? So you can ask like, there is a possibility that how do I get my apple, right, in the Google search or any search, right? Then it depends on your previous conversation, right? You could have asked about what is the different types of popular phones available. Then based on that context, it is able to show the list of Apple stores that is available in the country. Let's say you were interacted with the system with the talking about fruits, plants, and agriculture thing. Then the system is able to generate a solution is able to understand that you're talking about fruits, right? So uh, the 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 system or ML model which I'm talking about is able to understand and reason like a human being so that it can easily understand the context. So that is what is called semantic search. It's not only the keyword search, it can understand the human emotions, it can understand the human context so that it can be, pretty much act like a human. So that is what it is called. Possibilities is like the semantic search. So let's go to the slide. So as I mentioned, it understand the user intent, user emotion, understand the context. So how semantic search is possible, right? So uh, when you type a query, for example, there are a lot of natural languaging processing API available by the cloud providers, which analyzes intent, context, and meaning behind the query, right? So, and this query, natural language processing query is like extract all the entities, and it can come up with the identifying what exactly you are talking about, and then you have a knowledge graph. We call it like vector database, which I mentioned, which can be added. For example, it needs to search some of the information. How far is Delhi if it's from Noida? So those kind of information it doesn't have, right? It could have stored somewhere in the outside of the knowledge system. So it gets those additional. It's not only input and you prompting and your desired output from the system. It sometimes it need to refer to some external database for additional context so that it can process that and gives the results. It gives the ranking and retrieval also, right? Because sometimes you have to have a relevant match, right? So, Apple, let's say for example, you ask for the Apple iPhone, where can I get the iPhone, or where can I get the Apple iPhone? So it has to be the relevant and address, right? You cannot like show if based on the user. It can be like the user is living in UK, it should show the UK location. It should not show US location. So those kind of relevancy will be calculated and then it is shown. So that's a huge difference between the keyword search. For example, you might have used those search button in the any of your websites. Like for example, in your college website, you can go ahead and see there must be a search button. Like you can go and see like that is more of keyword search. It just exactly match. Let's say you want to type your name and say like, okay, it just matches the exact match and then it brings up. All right. So, but it cannot understand the intent which the behind you searching. For example, you want to know about what are the possible courses in the Master of Technology second year. So those are the questions. Let's say you want to ask it, just go and search if the exact match is found in the search system. It will return. Otherwise, it will say like it will not return anything. But the semantic search has a power. It has say like, oh, I did search your repository. I couldn't find anything. Is there anything else I can help you with? So it tries to understand the whole scenario and whole environment. So that is the power of a semantic search. I think I have covered a lot of concepts here. So I just want to take a break and see if you have any questions. Uh, a quick question, Krishna, like I want to make sure, like, this is how the pattern is because I always prefer to have a questions in the anytime. I mean, questions throughout my session, but how do we, in general, do this kind of sessions?
So, sir, can semantic search produce hallucinating results?
Yes, I mean every model. Yes, that's a great question, sir. Pendra, Dr. Pendra. So yes, if anything can produce hallucinations because you are creating, you know, with the help of LLM, which is like, it can do the hallucination. So again, the goal is to reduce the hallucination as much as possible. For example, for those who don't know, I mean, hallucination is like creating the content on their own because you are creating. So the generative solutions or search system here it can create the content on its own without the factual results, right? Without the factual content. For example, it can create story on its own, right? Because it know how to create the text content. It can just make some story which is not true, which can be grammatically correct, but it is not true. So that is called hallucinations. To avoid those side of hallucinations, Upendra, that's why we should use those RAG architecture, which is called retrieval augmented and generated architecture, to reduce those sort of hallucinations. So that is what we're going to cover as a part of system. So in summary, like, the search application anywhere, it can be a website, it can be mm, your office or your college or enterprise search application for looking for the candidates or looking for the researchers. Any search application all across the industries is being uh, redefined with the help of LLM search due to the fact that it does the semantic search. So that is the whole concept of this, semantic search, right? So uh, let's go to the next slide. So Upendra, just want to make sure, Dr. Upendra, sir, did I answer your question?
Yes, sir. Thank you.
Okay, thank you, sir. So the next one is, let's go to the next one. Uh, how this, see, these are the steps as a part of semantic search, but how this is possible in every cloud solution, right? They have a different, every cloud solution has a different APIs for all those steps. So this, if you bundle all those solutions together, you'll get the output of the semantic search. So now let's talk about RAG architecture, why it is needed. As Dr. Upendra asked, like, again, like LLM models or generative AI models or search solution or chat systems, it can hallucinate. Hallucinate is, it can create some information without that, which doesn't have any source of truth. So how do I avoid that, right? For example, how do I avoid this hallucination? It can be avoided or possibly reduced with the help of implementing RAG architecture. So ideally, you are not relying only on the LLM's output, which is like a foundation model. You are going to integrate this LLM output along with another database output, which is like a collection of your additional contextual information. And let's say you are building you are going to apply for an insurance policy from LIC, right? So a simple search like, how do I get a policy? How, or how do I get LIC policy? So LIC policy is pretty different from a state banking policy, or different banks have a different way of approaching the policy. So in that case, a LLM can provide uh, some generic answers or may hallucinate. For example, it can add those State Bank of India's policy to LIC policy. So that, to avoid that, you are grounding those results with the help of external database. When you say grounding, that's my solution. I mean, my talk title also. Grounding means you are trying to avoid those hallucinations with the help of grounding. Grounding is nothing but you are adding your contextual data. For example, LIC has a lot of policy documents, right? For example, you can ask LLM to read those documents along with its the source model. It can generate the response. So that would be pretty much close to accurate. So that is the reason why we should always have a contextual knowledge, which is possible with RAG architecture, to reduce those hallucinations and to improve your semantic search to have those more relevant content for your organization. For example, DTC Noida has specific context, like about the college, about the policies and all the stuff. But for example, Anna University in Chennai or Jawaharlal Nehru University in Hyderabad have a different policy, right? So uh, if you rely completely on the LLM, it may provide some inaccurate information. So in that case, if you want to provide specific information, you can provide those repository for, let's say, you're building LLM for DTC Noida, then you can provide your repository for all the policy document uh, in a PDF format, and like that way, it can just only talks about DTC Noida uh, policies, right? So that is a quick overview on how to implement, you know, RAG-based architecture for your search application. Any questions so far? Okay, yeah. So benefits of RAG architecture, which is like, it has a improved accuracy and factuality. When I say factuality, it's like you are grounding your results with the right fact. For example, it cannot generate a solution, cannot provide some inaccurate content. It won't provide some inaccurate content because you are grounding with another external database, which we call it as like vector database. So ideally, an architecture looks like a user or search user come and talk to a LLM or generate AI search solution, semantic search solution. Uh, it not only talks about this foundation model, but in addition to that, it talks about, I'll show this architecture diagram in a couple of slides, but it talks to the external database where the embeddings are created so that you get the accuracy and the exact truth of those search query. Again, as I said, domain specific response. For example, uh, yeah, for example, you're working for a bank and opening a bank account has a specific policy than closing a bank account or opening a FD, all those. So you can have a domain specific responses instead of pretty generic responses, right? Let's say, how do I open a savings account? If there is no RAG system implemented, if you search, ask the, okay, can you please give me the process of opening a bank account? So it's pretty generic. It doesn't specific whether it's a private bank or public bank. It's very specific. Go to the nearest bank and you know talk to the banker and get the application filled and get your savings account. But that is not we want, right? You want to have a specific bank, this address, this place, this area. How do I do it? Sometimes those banks has online facilities, some doesn't have on. So we need to have more specific response if we have this RAG architecture implemented in your semantic search application. So there are different ways to implement this RAG architecture. There are two ways. One is fine tuning your model, which is called like taking the foundation model from OpenAI. The biggest models right now is this Google or OpenAI or Meta's Llama model, and then you can fine tune it. Fine tuning is like you adjust the net weights of your networks, and you make some changes. And then in case if you have the data scientists, researchers who can work on the model, but it needs a lot of training data and a lot of GPUs and TPUs resources to train those models. So it's really cost sensitive and a very resource intensive operation. But RAG is like cost effective. It's a pretty less cost when compared to fine tuning. So some of the organizations that consume the generative AI model mostly prefers to go to RAG architectures instead of fine tuning the model. The fine tuning the model is you actually take the model, change the model. Instead of that, you can take the model, foundation model, and add some external references with the help of vector database to provide the accurate results. So that are the two ways of improving the accuracy or and to avoid hallucinations, whether you use your search or chat applications. Yeah, I think this is covered. So this is how the RAG architecture is implemented. I have given the Google Cloud source URL. I mean, so I can ping you in the chat. Also, after the call, you can go and read on yourself. It's pretty interesting to understand this. So let's say, which I talked about this LLM, this is like your generator, which is like your foundation model, which is frozen. Like you are interacting with either Google's Cloud Form, Gemini, and then you are not only relying on this, only the foundation model, but you want to add more relevancy with the help of adding this external knowledge, which I'm talking about, which is called a vector database, right? So let's say you are a user here, you start a search query here, like, that's how this retriever is a new component you can build with the help of all the APIs available from Google Cloud. What it does encoding the results, it does vector search. When I say vector search is creating the embeddings of all the data you have and then doing the semantic search on top of it, which is called as vector search, right? So any question? So this is pretty important topic, to have a grasp of how those RAG architecture works and how the how it helps the semantic search application, right? So the retriever knowledge will take the search questions from the user who's using the generated solution. It just asks this question. Even though it knows some of the answers since it is trained on the whole amount of data, right? So it can able to answer, but to reduce those hallucination and also to have a domain specific answer, you are talking to the external database, which is like the vector database, and then you doing a search among those vector search, and it retrieves the results, and the retrieved results will be ranked, and the answer will be shared to the search user. So it's pretty like 3 blocks, but there's so much has happened in those steps. This is clearly explain how the semantic search works behind the scene with the help of RAG architecture. So any questions or we can move forward? Okay, yeah. Let's go to the next one. So far we talked about the RAG architecture and how we are implementing this RAG architecture in Google Cloud. So it's pretty much similar for other cloud providers, for example, AWS, Azure, Oracle. But this is an example that I put it together for all of you to implement this RAG architecture, the cloud of with the help of Google Cloud Solutions. Right. So far we have seen the architecture. This is how those architecture is implemented with the help of Google Cloud Solutions. For example, you have a document corpus, which is like PDF, hundreds and millions of documents, for example, for your DT, for your campus, university campus, right? So it can be in the form of PDF right now in this example, but it can be about in terms of video. It can be an audio files. It can be images. It can be papers. Uh, it can be physical paper, which has a lot of content that can be converted into a PDF with the possibility of other technologies, such as document AI and all those stuff. So you, we call it like embedding. As I clearly mentioned during this call, everything is possible with the help of embedding, right? Embedding is nothing but any text. Every text in the in this world has the system will create embedding for it. Embedding is nothing but a floating point calculations for the word. For example, Apple has an embedding. Let's assume that it has an embedding of 0.0015. Then let's say you have an orange coming up, and then it has pretty much close to each other, right? Because those are fruits. For example, apple and doctor. Yeah, it can be stay close together because there is a proverb. Let me choose another word: apple and tiger. That can be not stored next to each other, right? So that is how the system stores those concepts with the help of embedding, right? You cannot it generates the embedding for each and every word, and those embeddings will be stored in a vector search. So vertex search is nothing but a database. We call it like vector database, right? Which stores the embeddings where you can run your search query on top of it so that it retrieves the right, tries to retrieve the right and accurate and specific results, right? So let's say how that, let's say how the flow goes, right? This is your organization data, uh, which is used to improve the LLM or your generative search applications. So this document data from all those millions of records of PDF is an example. Instead of PDF, it can be an audio or video or anything which can be a multimodal. So it creates these embeddings of everything, and then these embeddings will be stored in a database. This is pretty very crucial component of this architecture. The vector search is called a database. So similarly, you have a similar vector database in different. Pinecone is one of the most popular database available, which many people might have heard about it. Uh, so, and once the vector search, let's say a user coming in, I say like, how do I get to, you know, Bangalore to Mysore at the time of 9 a.m. For the specific day, right? So what it does is that it tries to create this uh, LLM, like for example, it uses the LLM for text API and create those embeddings for all those user query, and then it tries to come up with an answer, and then it gets the answer from these two external database, and then it provides the output. So what I'm trying to say is like, for example, this embeddings can have a weather specific information in this example. Let's say it's raining in Bangalore, then this weather, it just picks up the weather related information and then it shows that. And for example, it takes like 1, 2 hours if you are starting now at this time, right? For example. So this is a pretty common example, but similarly, you can ask any questions like, depends on the domain, depends on the solution you put. But the key concept here is how the vector search works or does the semantic search of all the document corpus or your source content corpus and how it does the query retrieval and provide an answer to a generative AI search solution. If I talked about it earlier, prompt is your input and query plus your relevant document is it, your prompt will be converted into your query plus relevant documents, in this case a document, and then answer will be provided to you. So it's not just a prompt and understanding and giving an output as what you ask for. It have this additional context created with the help of embeddings, API, and then again storing those API with vector search and retrieving those topmost uh, then it does the retrieval and ranking because you need to have again further level of granularity to provide the answer. So this architecture is pretty important. So this is where how this generative AI search solutions from this corpus of documents, provides a semantic search for your user search query with the relevant information, with factual information, which in turn avoid the hallucination. So, so this is the whole architecture. Similarly, you can customize this architecture for your needs. It can be a document instead of document. You can create a combination of documents plus audio and video. This we call as multimodal. For example, Gemini is a multimodal one. So what it does, it can understand the video, audio as well, and from the text and come up with an answer. So it's just not relying only on the text document. It can combine all of this. So that is where the real power of multimodal capabilities, will be shown. So any questions here? So pretty much we have 5 to 10 minutes of content. So I just want to make sure if you have any questions.
Means here we are interacting with the database or something, not only, I mean, not only using LLM, but along with that we are interacting with the database. Or if it is a database, means what kind of, I mean, database we are interacting, whether it is, I mean, relational database or something like that.
Uh, yeah, that's a great question. So it's not a relational database. So this database is called vector database, Bhagyashree. This is especially used for this generative AI solution. So relational database or the traditional NoSQL database is used for transactional applications, but this is especially for ML solutions. There's a database design which is called vector database, which is used to store those embeddings of the external corpus. So so it's not a relational database. It's a vector database. They call it as a vector database. It's not like typical relational database where you query this with the help of normalization like primary key, secondary key. No, it doesn't work that way. It's like especially for storing the embeddings. Does that answer your question, or do you need to go deep?
Yes, yes, I got it. But if we want to implement in something like real time, means do we have like anything like a platform like using I mean vector database, something like that?
Yeah, that's what I'm saying. Like every solution. Sorry, every solution has every cloud solution has those databases available, right? So you can use vector database. We call it in Google, but similarly, Azure has it. Azure AI. I don't know the database name, but if you search like Azure vector database, you might get the answer. So you can have those database depends on the cloud environment that you are working on. Let's say you want to open source, you you have a you can have those open source model which is called the pine cone as well. So that's how this the vector database works. So you don't need to create something. You can just create a similar to relation database, right? It's available in the market. SQL Server, IBM, or Oracle, right? Similar to that, we have a vector database available in the market provided by the different cloud providers.
Yes, got it. Got it. Okay. Thanks for the information.
Yeah, you're welcome anytime.
So that's
Yeah,
pretty good
yeah.
actually. I was, I mean, totally new to AI ML and this thing. And from past 5 days, I am actually totally new to this field. Like now I am getting into it.
Yeah, of course. I mean, it's initially you're right, Kishi, it's a little bit pretty challenging. I won't say it's tough. I mean, if you develop the interest and if you increase your passion towards it, it's a pretty easy thing to pick it up. So yeah, happy to help anytime. At the end of this call, I'll be sharing my LinkedIn profile also, and feel free to reach out to me if you have any questions beyond the session. I'm happy to help to the best of my ability. Yeah. So let's yeah. Okay, let's. I hope I answer the question by Kisri. Then let me go to the next one. So any guesses like the challenges, right? So any guesses like anybody like it doesn't matter. Like you can just give me any answer, random answer. I don't mind, but just see what are the challenges you can think of it with this RAG architecture, where it fails, where it get fails, right? It looks pretty simple, it is ticking all the boxes, like wow, this solves a hallucination problem, and uh, it it helps with the right answer, specific context. So do you know any one of you have an idea like where it may have some challenges? Any guesses? Okay, so let me. Okay, the knowledge, the first challenges could be the knowledge source selection, right? So uh, as an implementer or as a solution provider, you have to choose the right knowledge source. Let's say you gave a lot of knowledge source, you gave more than needed knowledge source. For example, you have tens and thousands of files specific to policies, but you are sharing those policies relevant to the current generation. For example, 2000 to 2024, you feel that this is relevant. And then maybe you have a policy document which was created long before that. So let's say you share the both, and the LLM model gets literally confused, and it provides a different sort of answers. So ideally, a person who implements the solution, who knows exactly what kind of knowledge source you are going to provide. So that plays a really key role. If your knowledge source is not great or accurate, your output is also not accurate. So what's the input? It's going to be the output, right? So the entire any AI model is all defined by the data. I think if you have seen it, you might have listened to this Friday course. Anything to do with ML engineering, ML's models starts with the data, right data. Right data, quality of data plays a key role in all those ML systems. So that is what this talks about. And sometimes the retrieval information can be a bit slow, so you have to make some tweaks here and there to improve your search. And then this, if you want to improve your search retrieval quickly, then you have to pay the price for it, right? So it has to be a right balance between the performance and the cost. So that is another challenge. And second one is numerical embedding, which I talked about, right? So uh, any text data or any data that can be converted in embeddings and then stored in the database, right? So uh, again, let's say you don't want to store embeddings for certain data. That case, you have to understand that you're going to face some of the hallucinations or data the the output of the system, output of the generated search solution may be less because you are concerned about the cost, and you want every embeddings you store on your system is a cost, right? Like for example, this bug I mentioned, relation database, like the amount of data you store is relatively proportional to the amount of the money you pay for using the data service. So sometimes you need a little bit of accuracy, but not, you want to spend all the whole words into the system. So you have to find the right balance. That's what like balancing the meaning, semantic meaning with the computational efficiency. So these are the major challenges with RAG architecture. But I have a question and answer next, but still I would love to have one quick touch on one quick topic like responsible AI implementation, right? So any AI systems has to be implemented responsible. When I say responsible AI, uh, it has to be without biased, right? So biased solution may tends to have a biased response, right? So biased output. So it should be avoiding of data bias, or like, because as a human, we are the human who developing those systems. So any system that is developed, any AI system, it has to be, you know, taken into consideration of data from multiple diverse set of data. For example, it cannot only focus on Asia. Let's say you develop a global search application, like, people may look out for someone from different background, right? So you have to include those, uh, those context as well. So you should not like have a bias towards, because as a human we are biased in our opinion. So it should have like, diverse set of people across a different region to build a universal or global semantic search application. So you can have, let me share another page with responsible AI implementation. So just give me a second. Yeah, I just want to quick run of these topics. So this is the recommendation from Google. So use a human-centered designed approach, because you have to involve human with accuracy, testing the accuracy of your results, because you cannot just rely on the ML system to make answers or predictions. So you have to make the grade the system. It is a continuous evolving process. So any ML system has training and monitoring. You have to keep continuously monitor those aspects, examine the data, which I talked about it earlier, understand the limitations of a data, test continues to monitor. So these are the responsible AI principle, for your AI development. So AI system is nothing. Once it's developed, it's not done. It's not like a typical application. Like for example, you develop an app for a food delivery, like, it's a pretty transaction directional application. But let's say in the same app, if you want to implement a chatbot which talks to the customer, which talks to the food owner, the people who are ordering, and understand their context with not with the keyword search but with the semantic search. These are the possibilities. These are the responsibility you have to implement, because person from uh, Hyderabad interact very different from a person who interacts with the system through Delhi, right? So they use different nuances, different languages, different dialects, right? So it has to be continuously learn those nuances. So it has to be like, you have to continuously monitor your system performance, because sometimes it may fail. There are a lot of possibilities since you're dealing with huge amount of data. So with that end of note, I am, I think we come to the end of the session. Let me see. Yeah, yeah. I think we have come to the end of session. Hope this session is useful to all of you, and let me know if you have any questions. Yeah, over to you. Please. Somebody posted in the chat. Oh, no voice. Oh, can you hear me, Dr. Chandrasekhar? Hello.
So you are audible the whole time.
Okay. Okay. Thank you. Thank you, Peter. So, anything else? Any questions? I am, before I share my LinkedIn profile and see, or okay. There is no questions. So, Krishnakant, ma'am, I mean, over to you.